Let me share my screen like before we jump in. Right. Okay. So whatever I have this drafted, um, so the content details. Right. So yeah. So before that, so thanks Shamuk for introducing. So we have or I have so almost 10 plus years of experience into SQL Server, and so I am a part of SME in Always On or high availability concepts, right? So I know so the Always On and pretty well, right? So I will try to give my best to so share my knowledge to you guys, right? So we'll uh, try to learn together, all right? So if you have any questions and in between, like, you can feel free to stop me and ask any questions, and we will also go through some scenario based, right? So troubleshooting setup. So this is completely so kind of understanding of the concept, and so then we will uh, go through from the basics, right? Like from the time like we configure the cluster, we configure the always on, so everything we will start from the basics to understand how the configuration works, right? So before that, like, we will have to understand the concepts, right? So we will mix together and we'll go through each and every concepts that we have in so always on series, this series, right? So in this we will include, I include so the performance of the always on, right? So you might have seen some performance issues in always on, that also will cover in this 1 second. Mm. So in this performance also I'll cover, right? So and then we have added few niche technologies or niche topics. One is I would say like TDE with always on. So that also we will cover, right? I'll show you how to configure or how to enable TDE, transparent data encryption with always on. Maybe people are not using much, but yeah, so like CDC will cover, right? Partitioning, so table partitioning, so if it is part of always on, so how to configure partitioning and all. So we will discuss that as well. Anyway, like replication we will talk, and we'll discuss about few other topics, right? So query store, extended events, and DMVs for always on, right? So we will see all so everything, right? So from the basics to the advanced and to expert level. So we will cover everything in this series, right? So as Shanmukh mentioned, so it will be around 1.5 1 month to 1.5 months. So maybe it's can a little extend, because so the uh, pace that we are going through, or if you have any questions, so like we will have to cover everything, so might go for extend, because I will try to cover everything in detail, even if it is late or if it is taking a little longer. So bear with me. So I'll try to explain everything, whatever I know, right? So this is all topics that we have. So hope you all clear what is the agenda. And I believe that everyone in this, like today's, whoever joined, like all are aware that SQL basic concepts, and so then you it will be a little. I'm not going to cover anything related to the SQL DBA, right? So I will cover only with respect to the high availability, and that too with respect to always on. So nothing much, like we will not cover database mirroring. We will not cover any other high availability technologies. We will talk about always on majorly, right? So I'll try to cover here and there, so the previous technologies that we have, But here in this series, like we will cover only the always on series. Okay, so if you have any questions, you can raise your hand and ask your question. So we will go through. Right. So this one, like, so we will, I mean, I'll go through just, so the basics, maybe it might not be, okay. So I mentioned like, so 1.5 month, right? So we cover 2 days in a week, and each day I require it 2 hours, right? So 2 hours session per day, like 2 days in a week, that is weekends. Then it will be 1.5 month. So almost around 30,
Yeah,
25 hours it would be.
yeah, Chandu,
Yes, sir.
we will cover always on failure and failback also, right? In this
Yes,
session.
yes, everything.
Yeah, thank you.
Sure, no problem. We'll cover that, and we'll cover even any RCS, right? Let's suppose, let's say failure happened, like you don't know when the failure happened, and so how to look into it. So I'll show you like how to look into and how to investigate, so that you will understand and you can draft your RCA. So like, so that you'll understand that part as well, right? So we'll cover everything.
Okay.
Right. So any questions before we start? So as I said, like today is just a kind of, demo. I will outline, then we'll wrap up, and it might not be 2 hours for today, like, but I'll try to, so wrap up this soon. If you have any questions, you ask, or if you have anything in your mind, so maybe you can ask before we start. I'll give you a minute time, so just let me know. I'll stop sharing for some time. Just a moment. I'll close some documents.
Chandu, could you please share this course content to me?
Your voice is low. What is that? You need course content?
Yes, yes, yeah.
Sure. I think Shanmugh can share that. I think he must have shared already, but yeah, if not,
Yeah, some changes were modified, right? So,
yeah. So whatever he has, that is the final draft. Like whatever I have, that is the initial draft of this document.
okay, okay, fine.
Yeah. Right. So right. So let's move on. So, and one thing to be clear, right? So I'm more interested in like, so to be a kind of, so interactive sessions than going in a monolith. Like, so if I'm talking like, I would like interaction sessions. Suppose if I ask questions, or if you have any questions, you can interrupt and ask, and we can discuss, right? But yeah, not many questions, so that we'll also have to continue our class as well, right? But yeah, be interactive and all, right? So I'll start, I'll ask questions, and maybe you will have to answer, or you answer whenever I, so ask for any specific, right? Okay, let's move on, right? So before we jump into the always on, right? So that I just mentioned, that always on master series, and before we jump into anything, right? So always on or any high availability, can anyone tell me why I need high availability? So why would I need high availability? So why I cannot maintain my servers without high availability? Audio is breaking. Mm, is it for all or all good?
In case of disaster, we require high availability.
Uh, 1 second, sir. Sorry, what was that?
In case
Sir,
of any
all
disaster occurs, we need high availability.
In case any disaster happens, we require high availability. Okay, before that, what is high availability? right? So we will talk about why we require and first understand what is high availability. To suit mission critical applications. Okay, so anything specific? What does it mean? Let's move. Let's understand, right? So what is high availability, right? So why we need high availability? We will talk, right? First, understand what is high availability. This is just English terminology, right? Like the high availability is nothing but make sure that uh, if anything, okay, someone is so that if one server is down, the app user won't feel the impact. That is correct, right? So high availability, even if one server is down, your application would not feel that impact, right? So won't feel impact as in your application would be able to sustain even one server is down, right? So that is high availability. So we have something called disaster recovery, right? High availability is nothing but even if one server is not available, then your application would be able to connect the database without any impact, without any much impact, right? That is what high availability is. Disaster. So disaster recovery, right? So I think someone mentioned, right? So if something happened, disaster happened, so you should be able to bring the database online so that your application should be able to connect, right? So let's take one example, right? So let's say we will talk more into, but let's understand this, right? So this is consider that one data center. This is another data center, or this is one region. We all talking about, so regions and all, right? So this is another region, region one, region two, right? So let's say within the region, you have two servers, and another region, you have, let's say, one server. You are using this as a DR, this as a high availability, right? So high availability is if one server is down within the one region, the other server will automatically take the responsibility of the primary. So it takes the responsibility, or oh, in our terminology, we call it as a failover or whatever it is. But let's understand, if this is down, so the other replica will take the responsibility of your application redirect, application connectivity, right? So then this is what we call it as a high availability. The data is highly available. So what is this? Let's say this disaster happened. The entire DC is down, data center, or entire region is failed. Whatever, like any catastrophic error or anything, like, so anything that it matters, right? Power outage or whatever, like we call it as, the entire data center is down or entire region is down. So what will happen? Then this will act as a disaster recovery. There is a disaster happen, and I'll have to recover my database to, so make sure that application is at least able to connect and process their load, right? So that is what disaster happen, disaster recovery, right? So high availability. So if the high availability, the data is available, right? So the so application would be able to connect even one server is not available. The application connectivity would be transparent, right? So transparent as in, like, suppose application connectivity redirect automatically, right? So application doesn't even know much, right? So whether there is something happened within the server, because immediately the failure happens or immediately the role will be changed and your application will be connected. So your application would not feel the impact, right? So because your application is able to connect, redirect. And if the disaster happens, then your database on the DR side, you'll have to bring the database online to make sure that your application is able to connect, right? So this is the high availability and disaster recovery. Now, that's fine, right? So we were talking, so the high availability and disaster recovery, right? So what would happen to the standalone, right? So if it is a standalone instance, so that is where like we will understand why we require a high availability, right? Let's say I have a standalone instance. This is only instance that I have. So if I have an instance, if something goes wrong to this particular instance, right? So what would be the solution? So we don't have any kind of backup servers where it can takes the responsibility of this, right? So you will not have a so another server to recover the database faster. One second. Right? So you will not have any backup server to recover the database faster. So you'll have to go through a different route and all, like, so backup, restore and all method. But let's say this instance itself is down. So then it will be uh, difficult to bring the database online, right? So let's say you have a backup server. What will happen? So this another server would be available. Even this has some issue. Another server would be available, right? So this is what we call it as a replicated server, right? So that data will be replicated. We will talk that later. But for now, understand that the high availability and disaster recovery, the terminologies that we are talking about, right? So now standalone, it is tough, right? So and another reason that we have, so the high availability disaster recovery. So every organization, right? So every company that it matters, they will have the project, right? So let's take in general sense, general terminology. Every company will have a client, right? So and get the project from the client. And whereas we all DBAs or database engineers who are working on the database, SQL Server database, they support that application or the client, right? Now, let's say there is some issue happen. If there is an issue happen, so how you will recover, right? How you will recover and how soon you will you would be able to how soon you would be able to recover, right? How soon? Understand, like that word that we were talking. So how soon, like, so what would be the time, right? So how soon you would be able to recover the data, a database, and how much, so data loss, right? Less is the better, right? So how much data loss recover, I'll put in this way, recover with minimal data loss, right? So these two any application or any client they need, right? So any client that it matters that we work on, they look for these two. How soon you would be able to recover? So what is the recover? What is the, what is the procedure to recover the database with minimal data loss, right? So these two will be an agreement called service level agreement, SLA. So we have some SLA with the customer stating that if anything is going right, so I will get a response. So we will talk about, so SLA later, but for now, understand that anything happens, right? So anything happens, I should be able to recover your database within some extent or within some point in time, right? So we will have that SLA with the client or with the application, right? So to meet this SLA, we should have to meet these two major things, right? So what this and what this, that is where our next topics, right? So we have something called recovery time objective. We have something called recovery point objective, right? Let's understand that what is this recovery time objective, right? So this is what I mentioned here, this one. How soon, right? So recovery time objective, let's say there is some issue happened at 10 o'clock, right? So if 10 o'clock happen, how soon you would be able to bring the database online, or how soon you would be able to make application bring it online, right? So it doesn't matter, right? Application or client doesn't matter whether you would fix that issue or you would have a different approach to sustain the business, right? So this is what it is, recovery time objective, how soon you would be able to recover the database so that application would be able to connect your database and proceed its load or proceed its work. So next one is recovery point objective. So recovery point objective. Okay, so SLA, like if you see this time, right? So this diagram, so this is what the time to recover, right? So how much time it took to recover. Okay, so recovery point objective. Let's say uh, let's say I have 1 GB of data, right? So 1 GB of data is processing, right? If there is a disaster happen or if there is a failure happen, how much data, what is the way you can recover with minimal data loss, right? So what is the way that you can recover with minimum data loss, right? So recovery point objective, right? So the ability to accept potential data loss from an outage, right? So there is a disaster happen and you want to recover it from the disaster, right? So this is what it is, right? So any application or any client it matters, they mainly bother about the recovery time and the recovery point. Let's say there is something happen, and if you say that, so you will have uh, around 10 gigs of data loss. I don't think anyone would be accepting, right? So 10 gigs of data loss is very huge. Or let's say like you go and check, like, go and tell that uh, there is a disaster happen and I don't have any solution to bring it sooner, right? Then you are not meeting your RTO. If you cannot bring the database online within so a few minutes maybe, or whatever, like, so you call it as, then there is no point of having high availability, right? So if you don't have a high availability, or the reason that we maintain high availability is to have this RTO and the RPO. Recovery time objective, recovery point objective. Let's say, for example, there is something happened here and disaster occurs at this point, right? So the disaster occurs, right? If there is a disaster occurs, like how much time you took to recover the database is called as recovery time objective. And this is the data loss. I'm okay. Like if 1 GB or 2 GB, whatever data loss is okay, but at least my business will be up, right? So in that case, we bring the disaster recovery online so that your application would be able to connect and proceed its load, right? So this is the RTO and RPO that we have. So we all work on this RTO and RPO. And the main reason that we have a high availability concept is to maintain the recovery time and the recovery point. Okay. What happened? Right. So this is we were discussing SLA, service level agreement, right? So there is an agreement between your client and the organization to make sure that, like, so the uh anything, like, so if something happens, so you are telling that application team or the client saying that, like, I can recover the data sooner, right? So that is what it is, the SLA is, right? And it's just a high level. It can be anything. Let's say, for example, you have a company and you have a client and where they raised a ticket, and SLA can be anything, even if the response time, how much time it took for you to respond, right? So that is also a part of SLA, service level agreement, right? So there are some ITIL process, right? I'm not going to touch into, but if you understand that, right? So that is like a minimum 1 hour, 2 hour, whatever SLA that you will have based on your organization. So I'm not talking about that specific. I'm talking only with respect to the high availability area, high availability concept. Service quality and availability and responsibility. Okay, it defines based on the RPO and RTO of the organization requirements for SQL Server disaster, right? So it all depends on, right? So, right, so disaster, that you will define that SLA. Cool. So, right, so RTO, RPO, and SLA. So if you have understanding on these three, so we will go forward and see, right? So in just a high level, we need to meet a SLA, service level agreement, to make sure that the data is available and you will recover the data with a less, I mean, you would be able to recover the data in a less downtime. Less downtime is again like it is kind of it is an outage or downtime or a down, whatever synonyms that we have. The application is down because the database is not available. So that is where it is the downtime, right? So how you're defining, like, what is the how soon you would bring the database or application online so that you will minimize the downtime of your application, right? So, or even if you bring it online, so what would be the minimum data loss that that application can sustain? That is your recovery point, right? So what is the recovery point that we have, right? So that agreement you will have with the application or client, and you'll have the recovery time and recovery point, right? So we will talk that further, like we will talk about, so how you will maintain that recovery time and how you will maintain the recovery point. Right. So these are all just causes of like, so downtime of your application, right? So or application or the database that it matters, right? So it can be a planned downtime. So how the high availability that helps. Let's say, for example, you want to apply some patches or you want to do some maintenance. Either it is a Windows patch or it is a SQL patch, whatever it is. Let's say you have a standalone server. So if you have a standalone VM and if you want to perform any of these maintenance activity, right? So what you will do? So you will have to get the downtime of the application, the extended downtime. The reason that I mentioned extended downtime, let's say you are applying patch. While applying the patch, we all know at the end of the patch, it will stop and start the SQL service, right? So in between or end, whatever it is, it will stop and start the SQL services to make sure that the patch is applied. Let's say, for example, the SQL service doesn't come online for whatever reason, right? It can be a script upgrade or it can be anything. The SQL service doesn't come online. So then what happens to the application which connects to this database? Let's say it is a standalone. Standalone is nothing but a one server that we have, right? So it's a kind of, so general terminology, right? So we have only one server as called as standalone, and application is connected to this, and you are applying or doing some maintenance activity, that is your Windows patch or SQL patch, whatever it is. And if SQL doesn't come online, then your application would have a extended downtime, right? So your application will have an extended downtime that can leads to you are breaching your SLA, right? So breaching SLA is nothing but you are committed to one uh, time or one value to the client and you are exceeding that, right? So that is what we call it as a SLA breach, right? So now this would be difficult. Next one is upgrade. Let's say, let's say you have a standalone. Again, the same scenario. You have a standalone and you want to upgrade from 2012, whatever, like, version it is 2016. And I want to upgrade from 2012 to 2016. So let's say you have a standalone server, right? So, and if you want to upgrade, let's say it is a side by side or in place, whatever it is, and you want to upgrade. So let's take that you want to do an in-place upgrade because I don't want to change any operating systems and all, and I don't want to change any alias or whatever that I have, right? I want to upgrade the same instance. I want to do an in-place upgrade. So what will happen if it is a standalone? I'll have to just go ahead and update this instance. And again, the same thing happens to this, right? So let's say your application is connected to this and you'll have to have an extended downtime. The reason I mentioned extended downtime, we'll talk. So extended downtime, even for the upgrade, to make sure the upgrade is complete. I mean, until upgrade is completed. The reason extended downtime, there are many reasons. One, let's say the upgrade might have failed after some point, right? We all know, right? So how in-place upgrade works, I'm not going to discuss, but just a high level. So there is a no return point, right? So let's say you are upgrading your SQL Server in-place upgrade. So it will go here, upgrade. So up to this. So this is where we call it as a no rollback point or no return point, where this point or after 50% or whatever it is, the existing database files or existing database instance will be deleted or uninstalled and start installing the new instance. That is your 2016, right? Up to this, it will try to install or update the existing files. And once it reaches this no return point, then it will uninstall the existing one and start installing 2016. Let's say whatever reason that this point is reached, crossed, and 2016 installation failed. So you will not have 2012 and you will not have 2016 both, right? If that is the case, what will happen to your application if it is a standalone, right? Assume that, right? So you don't have any standby servers, right? So then you're planning to do an in-place upgrade, and it is failed after some point, then your SQL 2012 gone and 2016 is not installed completely, right? Then you have an extended downtime until you again do the fresh installation and restore whatever backups that we have, right? So that is the another scenario that we require some kind of backup. So the reason that we have a high availability is mainly for this, right? If it is a standalone, if something goes wrong to the primary, then secondary or whatever, like, so the standby server should take responsibilities, right? That is what these are the planned. These are all unplanned downtime, as discussed earlier, right? If there is a disaster happen at the data center itself, or individual server failure, some IO subsystem failure, or it can be a human error. It can be a human error. It can be anything. It can be anything, it matters, right? So if these are the scenarios, then if it is a standalone, you would not be able to, or you might be able to, but you will have more downtime. So you cannot meet the RPO and you cannot meet the RTO as well, right? So that is how this was. Just a moment. Mm, right, right. So these are the causes for, so whatever data loss or downtime and all, what do we need, right? So we'll have to minimize or avoid the service downtime, right? So let's say, for example, you want to upgrade your SQL server. What if you have a two servers as a group or as a, so members as a high availability, whatever we call it as, and if you want to upgrade, right? So instead of upgrading, let's say your application is connected to one. Obviously, your application cannot connect both. Your application will be connected to one. So second one is considered as a standby. Now I want to perform whatever maintenance that I'm processing, either upgrade or either it could be, so the applying a patch, either SQL or Windows, whatever maintenance that activity that I'm doing, I can do it on the standby server. I'm just using the standby word because uh, I don't want to use any of the secondary or whatever that, right? So just I'm using a secondary as a standby or another server. You can consider that, right? So we can proceed everything here. Even if upgrade is failed, then you should be able to recover without much impacting to the application, right? You should be able to recover your secondary server or the standby server without any impact to the application. That is there, right? Now, when components fail, right? So anything, it is a planned activity. So we have another side of the coin, right? So we have a unplanned. So unplanned, it can be anything. So anytime it comes, any situation, right? If this has some issue, this server has some issue, then it triggers automatically. It triggers failover, whatever we call it as, right? So then the resource will be moved and this will become primary so that application would be able to access this database, right? So what does it mean? If something goes wrong to one server, then the other server will take responsibilities and then application would be able to connect, right? So that is the reason that we will have a high availability solution, right? So it will have this one. The advantage of high availability is to minimize or avoid service downtime, right? So then second advantage of having high availability is to support an automatic failover. So what will happen if there is automatic failover? So would it help with recovery RPO or RTO? Can anyone tell me? There is something happen, failover happen, and your application is connected. This secondary took responsibility and your application would be able to connect. So what we call it as?
That's failover.
Sorry?
Failover.
RTO.
Failover, correct. So this is failover only. But let's say, for example, okay, I'll put in this way, maybe failover happens. So let's say, for example, within failover, like how long it takes, like around 30 seconds. Okay, I'll put in a more specific. Let's say failure took around 1 minute, for example, right? Failure took 1 minute. Now, uh, something is not available here, right? So whatever data that we have, like let's say 100 records that we have on the primary, and after failover, so it has only 70 rows or records. So 30 records are lost, right? So 30 records that we have are lost, right? Then the recovery point and recovery time. So can you define like how much, what is what here?
1 minute RTO, 30 records RPO.
Correct. So 1 minute is your recovery time and 30 rows lost, that is your RPO, recovery point, right? So at what point you are able to recover your data, right? So that is what this is, RPO, recovery point objective. I mean, so I would say like, so 30 records are lost, but what point you were able to recover is this point. The 70 rows you are able to recover, right? So how much data you would be able to recover is basically your RPO, right? So this is the data loss, right? So RPO is basically a data loss. RTO is a time it takes to bring the application online. This eliminates single point of failure, right? If you have a high availability, then you would eliminate a single point of failure, right? So if something goes wrong, then your entire server would go down, right? So you are avoiding that single point of failure by having high availability solutions that we have, right? So now this is again, right? So suppose, let's say, for example, I have a standalone instance. What are all solutions that we have to meet the RPO or RTO? So RPO, RTO, general terminology, it can be anything, right? So it defines how much time and how much data loss. That's it. So even if it is a standalone, you still maintain that RPO and RTO, but it all depends on the metrics. Now, so if it is a standalone server, only one instance, right? So you have an option to recover your data by restoring your databases, right? Let's say you have a standalone and you are planning to upgrade. So before upgrading, you will have to take a backup of the databases, right? Everything you will take the backup, right? We are not going to discuss about the migrations and all, but migration upgrading and all, but you are upgrading, and you before upgrading, we'll have to take a backup always. This is a thumb rule that we will have to follow. That's it. So you'll have to take backup of your databases. Now, there is something happen, right? So there is something happened during the installation or during upgrade, whatever it is, and your instance is gone, right? So you're not able to connect or not able to proceed with the upgrade. Then you will have to restore this database, right? To make sure that application is able to connect this. Second thing, let's say this is a planned, that is a planned. Let's say that every day you are taking in the night backup. Night, let's say for example, 11 p.m. you're taking a full backup. Unplanned happen at 6 p.m. Every 1 hour you're taking log backup. Let's consider. Every 1 hour you're taking log backup. Every day, 11 p.m. you're taking full backup. And 6 p.m. disaster happened for this instance, right? So disaster as in like anything. Database is corrupted, for example. Database is not accessible. Database is gone. Now you want to recover the database, right? How much, like how you will recover? You will have to restore the full backup, the last day full backup, and you will have to restore all the log backups. Let's say, I'll take this scenario. Um, every day, 11 p.m. full backup. Every hour log backup. Okay. I'm talking if it is a standalone, right? So standalone, I want you to answer standalone server, and disaster happen or the database is corrupted or crash happen at 5:58 p.m. Let's say. Now I want you to tell what is the procedure to recover your data, right? And what is the RPO and what is RTO here? So I'm not bothered about so the exact value for RTO, because that all depends on the speed that it process. But what would be the approximate or how you will define this, right? Can anyone tell me so this is the scenario that I have. And standalone 5:58 p.m. there is a crash happen.
So we take the full backup every day, right? 11 p.m.
Mhm.
Then transaction of every 1 hour.
Mhm.
Then crash happen 5:50, 5:58 p.m. So that means 5:58 p.m. We already took the transactional backup of 11 to 12,
Sorry. So
12
what
to
is
1.
no. So what is the first you will restore?
You say what?
No, tell me again, like what is the solution that you are telling?
No, I'm just saying that we
Hmm.
already took the transactional backup from 11 to 12 to 5, right?
Correct.
So
Every 1 hour,
now,
every 1 hour log
mhm,
backup happens.
Yeah, so after 11 p.m., we took the log backup from 11 to 12, 12 to 1, 1 to 5 p.m.
Correct.
So now we have lost data of, I think that will be 5 to 6. It's not up to 6. We have like 58 minutes data lost, which is RPO.
Which one?
No, RPO.
You mean this?
Yes, yes.
Hmm.
Then, where will I categorize this RTO? RTO will be taking the full backup and then taking the transactional backup from 12 p.m. to 5 p.m.
What is that?
Then restore the full backup and then restore the transactional backup. The last full backup of 11 p.m. Then restore the transactional backup from 12 p.m. to 5 p.m.
Correct. Exactly.
Yeah.
So exactly. Thanks for that, Femi. So we have 58 minutes as a recovery point, like, so the data loss, whatever we call it as recovery time, right? So recovery time. So it all depends on like how much, what is the database size and how many files we are restoring and what is the restore time. It all depends on the time we would be able to recover the database. Let's say, for example, the backup size is around 1 TB, 1 TB. So the restore would definitely take at least, depends on the speed of the, so drives that we have, at least 4 to 6 hours, let's say, right? So that is at least, right? So you are restoring. Then you will have to restore all your transactional log backups until 5 p.m. right? So this time can be hours or even it can go for a day or plus, right? So that all depends on the database size. The recovery time would be extended. So if that is the case, your application would be down for extended period of time, right? So that is the only solution that we have if it is a standalone, right? This way, you are not meeting your SLA, right? So we have limited options to meet whatever like recovery point or because we have to restore from the backups, right? So you will not have much options and you will not be able to meet the SLA on time, right? So this is the drawback. To avoid that, we have something called high availability concepts. Right? Let's understand what are all high availability concepts that we have until 2012, right? So until 2012, can anyone tell me, so high availability and disaster recovery solutions that we have until 2022, 2012, sorry, until as in exclude 2012 up to 2008 R2, you tell me, because 2012 we have something called always on, but yeah, or you can consider that except always on, like what are the high availability and disaster recovery features that we have till today? Anything should be fine.
I think before that 2012, we have log shipping, I think, and mirroring.
Log shipping, I want you to define what is this as well. I mean, what is this as in this considered as a high availability or disaster recovery, what it is, or both? So I want that as well along with this. So mirroring.
You mean log shipping and mirroring?
Log shipping.
Mm-hmm.
Yeah, so mirroring and log shipping. Yeah, I'm just using this two in two different
It's
lines.
DR.
Which one is DR?
I believe both are DR.
Both are DR. Okay. DR. Okay. What else we have?
I don't know if replication work with those one. I never
Okay,
used
I'll
that
put in
before.
this way. HA. What are all we have HA? What are all you have DR for DR? You mentioned like these are for DR.
Yes, I believe. Yeah, these are there. Yeah.
Yeah, that's fine. I just want your opinion on that. What about what else? Like anyone? Shay, yeah, you mentioned the same thing, right? Log shipping and mirroring. Cool. So anything. So any thoughts that you have, Shay? Like either it is mirroring, either it is a DR or whatever. Like clustering is high availability. Clustering, correct? Clustering is high availability. Log shipping is high availability. Santosh, can you tell me like how log shipping is high availability? So, and also you mentioned Santosh, mirroring is, what is that mirroring? Is high availability or disaster recovery?
Disaster recovery.
So mirroring is for disaster recovery. Okay. So you understand the the difference between disaster recovery and high availability, right? So high availability, let's say in simple terminology, high availability would automatic failure works, automatic failure happens. If it is a disaster, there is no way that we have an automatic failover. So we'll have to bring it online. So that is what it is, a disaster. High availability, let's say, for example, this is one data center and this is another data center. You have two servers here. So you have one server or two server, whatever it is, DR, right? So this, let's say it is a high availability, it maintains, right? This uses for DR because it is a different reason and all. We will talk that later. Let's say this server is down, the automatic failover happens and application would be able to connect your databases. So this is what we call it as a high availability. And whereas disaster recovery, the entire data center is down, the failure would not be automatic and you will have to bring it online manually. So it can, I mean, we will talk that data loss and all, but yeah. So this we will use for disaster recovery. So if there is a disaster happen to my primary data center, then only I should recover this server. This is what the high availability and disaster recovery. So if you have anything changed in your mind for these, you tell
Yes.
me. Otherwise,
Mirroring also it will comes under HA.
mirroring also comes under HA, correct? Anything else that we have?
Replication under disaster recovery.
Replication under disaster recovery. Okay. Anything we have in the high availability? So mirroring is part of high availability as well as disaster recovery, or only high availability, or only disaster recovery?
Mirroring is only high availability, not a disaster recovery.
Mirroring is only high availability, not a disaster recovery. Okay. Okay, so we'll get to that point, but for now I'll just
Yeah, in
Actually,
mirroring,
you use the failover in high availability.
automatic failover and manual failover in mirroring.
So what is the point, right? So what you want to
It
tell?
comes under HA and DR, I would say.
It's under DR.
Both HA and DR.
HA and DR, right? So HA and DR. Okay, correct. Yeah. So whatever you guys mentioned, that is absolutely correct, right? So we have a mirroring, we have a clustering as part of high availability, whereas so mirroring, so you can use for disaster recovery as well, right? So you can use mirroring for mirroring as a disaster recovery as well. And log shipping is always a disaster recovery. The reason log shipping is disaster recovery, we don't have automatic failover. We will talk that like, high level, but we don't have a automatic failover. Whereas replication, so maybe consider that as a disaster recovery solution, because we don't maintain that, so high availability concept, right? So if something goes wrong, your application has to point your replication connection string later, right? So whatever it is, so it is considered as a disaster recovery. So it is not comes under high availability, right? So high availability only with respect to failover. Second thing, the application, we should not change anything in the connection string. Let's say, for example, failover happens. Application should be transparent, right? So application should be connect wherever the primary is, right? Application should be able to connect wherever the primary is, right? So that is what the high availability, main feature of the high availability. Otherwise, there is no point, right? So we do have something called peer-to-peer replication, like everything will be replicated and all. But again, like if something goes wrong, your application has to change the connection string. So without changing the connection string, it wouldn't happen. The same thing applies to log shipping. Log shipping, if something, you can do a failover, right? Of course, like you can do failover of the log shipping. You can, this is primary and this is secondary. And if you want to bring this as a primary and this as secondary, that is possible. But your application, this is a manual intervention and something is manual. Either failover is manual or changing application connection string is manual, right? So this doesn't comes under high availability. High availability, the concept of high availability is without any manual intervention, application should be able to connect your database. That is the high availability feature. That is the high availability like a property that we have. Let's just a high level, let's understand this, so the what we have, right? So to uh, traditional way of high availability or disaster recovery concepts. So I'm not going to discuss detail of this, but just understand that log shipping that we use for disaster recovery, whereas the you will have the primary and secondary, whatever it is, and you will send the transactional log backups from primary to secondary, and secondary will keep restoring the databases, restoring the backups, right? So this we use just for disaster recovery. If something goes wrong and you don't have any other solutions, then you can use log shipping for to recover your data. So log shipping we can use to recover your data, right? You can have multiple secondaries in the log shipping, right? Suppose if you want to create multiple secondaries, you can use log shipping to have the multiple secondary databases, right? So this is the log shipping that, so just a high level, right? So we're not going in detail. I assume that you at least have this understanding of log shipping and at least configuration of the log shipping. So at least the recent days, right? I don't see any configuration of log shipping or mirroring. It's very less until you have a old systems where you have the log shipping configuration or even database mirroring. Now, so we have something called database mirroring. So database mirroring is the one, so it maintains the copy of your data, right? So the mirroring itself, it maintains the copy of your primary server. So you will have the mirror, right? So you'll have the two servers and you want to mirror the same data to another server, right? It maintains the same copy of your data, right? So that is what database mirroring is, right? So the data will be replicated or the data will be mirrored on the secondary. primary, and you'll have something called mirror server, where you'll have the data replicated on the mirror server. Now, so we have this, right? So why we call it as a high availability? So we have something called witness, right? So we will talk about so the quorum and all, but just understand that witness is one way, witness will help for automatic failover of your application, right? So, automatic failover of your database. So with this help, right, we can configure mirroring for automatic failover. So if you configure mirroring for automatic failover, we call it as a high availability concept, high availability. Let's say you don't have a witness and you don't have a automatic failover. Let's say you are using this for only replicating data, and whenever the primary down, you will bring the secondary online. So we call it as a disaster recovery. So mirroring you can use for high availability and disaster recovery. How you configure it matters, right? Suppose if you configure with automatic failover, then it is considered as a high availability. And if you consider, or if you configure mirroring with manual failure, or mirroring without automatic failure, we call it as a disaster recovery, right? We call it as disaster recovery. But the drawback of mirroring is to have one particular database itself, right? Suppose you have a primary and you have a mirror, principal or mirror, whatever it is, and you have only one database will be replicated here, right? So only one database would be, only one secondary would be available here to replicate the data, right? So if this is gone, so automatic failure would happen. So what if both are down? If both are down, there is no point, right? You would be able to get the data, right? So that is another drawback of with your database mirroring. Now, to avoid this, let's say, I will just put it this way. In database mirroring, let's consider this is your primary, this is your secondary, right? Primary or principal and witness. You can consider that principal and witness. And it is configured for high availability. Let's say, example, and with witness server. Witness is just like a, so it is acting as a vote. So we will talk about the quorum. That's why I'm not stretching to this witness. We will talk in detail about the quorum and all. But for now, understand that it is another server kind of thing. Right? So it will maintain the high availability, whatever that we have. So principal and witness, like you configured, so you configured with a without automatic failover. It's considered that it is a manual failover, right? Or high performance, right? So that is what we call it as a high performance. If it is a async, or if it is in so high performance mode you set. So there is no automatic failover. It is considered as a disaster recovery. Now, if these two are down, then there is no point you would be able to get the data, because in mirroring you'll have only one-to-one, one database and one secondary. That's it. Or even you consider that you have a mirror witness and you configured as a high availability, high safety, right? So high safety, that we call it as high availability, you configured between these two. So automatic failure would happen if primary is down, secondary will online. If primary is um, down, and automatic failure would happen. Let's say these two are down. If these two are down, what will happen to the HA? Is down. And you will not have any disaster recovery solutions now. So you cannot bring anything, right? Again, it is considered as a the same scenario that we were talking in the standalone, right? You will have to take a backup, restore, whatever that you'll have to do. To maintain high availability and disaster recovery, can we do that with database mirroring? Both I need. I need both. Both I need for database mirroring. So far we were talking either database mirroring works with high availability or disaster recovery, right? Both cannot work because you have only one-to-one. One database, database one, database one. So you have only two servers. It will maintain the data. Either you can have high availability or you can have disaster recovery. So with database mirroring, can we have high availability and disaster recovery? If yes, how? If no, why? I don't know. Or is it possible? First thing, high availability and disaster recovery.
No, it is not possible.
It is not. Okay. Not possible. Okay. Anyone else?
So that means you have to choose a side. Is either you use it for DR or you use it for HR.
Correct. But I wanted to use for high availability and disaster recovery both. Is it possible?
For high availability and disaster recovery,
Both options.
I would say it's possible with witness server.
No, witness is just for maintain the quorum. I mean, maintain the so the server details,
The
right? So
automatic
data,
failover.
yeah, correct. Automatic failover. The data will be replicated between these two only. Witness server doesn't have anything. Only these two you will have the data. Okay.
Yeah, it's kind of possible, but it's not good. It's not really 100% HA and DR.
Right.
But it's, yeah, it's kind of possible.
Kind of possible or not possible?
Kind of possible.
How?
Because although it's one-to-one relational, but at the same time, I think you
Mirroring.
can
I am
conflict.
talking only the mirroring, not listener.
Yes.
Mm-hmm.
It's hard because it's not even accessible.
It's not possible.
It's not. I don't think it's possible.
Okay. Let me add.
I think it can because it can do it like auto failover. It's a one-to-one relationship, but at the same time, your database can be synchronous or asynchronous. So if it is synchronous, that's auto failover. So if anything happens, then it's going to fail over.
Correct. Correct. That is high availability. If it is asynchronous, then we will have to do it manual, whatever it is. We call it as a disaster recovery. Right? So if it is a one-to-one relation, either you can configure either synchronous or asynchronous. Right? So either it can be a high availability or it can be a disaster recovery. But the question is, can I have high availability and disaster recovery with database mirroring concept? Both high availability and disaster recovery. That is the question.
So what if you configure your primary asynchronous and your
No, I wanted
synchronous.
You to think out of this box, right? So out of
Yes,
this
it's
box
possible. It's possible. It's
out
possible.
of how?
Because it depends on how you configure it. So you already give the expo, the link to the answer. So it's possible, depending on how you configure your mirroring. So if you configure one as asynchronous, then one other one and asynchronous. So that means
No,
they
no,
can start
no.
for.
See, I think you are confused, right? So this is the database mirroring. If it is that, I'm not talking about the always on. So I think you are going into always on direction, right? So this is database mirroring. You will have one primary, you will have one witness. No other servers will be in the database mirroring. So you will have primary and you'll have the secondary. That's it. So primary or principal or and witness. That's it. So you will not
Okay.
have a third server when involved in this database mirroring. Only these two.
Man, you have to
Okay.
tell us the
Like
answer.
no, like wait, like
Uh-huh.
principal and the witness, or the principal and the mirroring.
Principal. Sorry. This is mirror. My bad. So this is mirror, not witness. This is mirror server.
Who is the endpoint?
Sorry,
Who is the endpoint?
where is the endpoint?
Endpoint. Yeah, yeah.
What do you mean?
Endpoint is the communication over the internet, right? The communication between the.
So endpoint would be there in both the servers.
Okay.
Endpoint would be there in both servers. So without endpoint, you cannot even establish a connection. Okay, so I'll tell that, right? So I would say like it is possible, HRDR, along with the database mirroring, you can have this log shipping. Right? Let's say you have a database one and you configure database one with database mirroring, and the same database you can configure for log shipping. In this way, you will maintain the high availability and disaster recovery. Between these two servers, you will maintain the high availability, and the principal and the third server, which is configured for log shipping, is acting as a disaster recovery, right? So with this solution, it is possible to have the high availability and disaster recovery with database mirroring and the log shipping with the help of log shipping, right? So I don't know if any one of you tried, but if not, I would request you to go and try this database mirroring and all, so log shipping, so that helps to maintain this as a disaster recovery. Now, if any both are gone, log shipping database is available, and you still have this as a DR, and you would be able to bring the database online. But only thing that you will have to change your application connection string pointing to this server, right? Pointing to the log shipping server, right? With log shipping and database mirroring, high available disaster recovery is possible, right? Is it clear? Okay, where I am.
I have a question.
Yes.
So in this case now, let's say we have a mirror, we have the principal and mirror inside, and we want to maintain HADR.
Mhm.
Can we use replication as a third server instead of log shipping?
Replication, yeah, you can use, but replication, it's a little complex, I would say, because you'll have to configure replication and that articles has to be transferred, and you will have to maintain certain jobs and all, so yeah, that also can be used, but what data you will be replicating, right? So how many tables you will be replicating, and to replicate, to use the replication, you will have to have this primary key, right? How many tables you'll have primary key. So though all you'll have to consider. Yeah. So that also you can use.
Oh, that's it. Thank you.
Yeah, no problem. Right. So, and another option that we have, our favorite, like most of us definitely work on the cluster, I'm sure, right? So before we have always on, like we all worked on the clustering. The reason that we have a clustering is very popular. The reason it's very popular because it maintains the high availability at the instance level, right? Even if the entire instance is down, the other replica or other server would take the entire service's responsibility or entire responsibility of your resources, right? So this is the instance level high availability. So far, we were talking about the database level high availability, right? So database level. So far, we were talking about the database level high availability. Let's say you have 10 databases in the server. And if you want to have some kind of high HADR solutions, right? So we have to have so much work to configure, right? Like the database mirroring, log shipping, or whatever, like, so options that we have at the database level that we will have to configure individual database and we will have to maintain individual databases. So with failover clustering, so it is monitoring or maintaining for entire instance level, right? Doesn't matter how many databases that we have. So entire instance, it will monitor. And if something goes wrong to that particular server or particular instance, automatic failover happen to another node, the complete resources, including everything will be failover to the other node, right? So in everything, right? So everything will be failover to another node, right? So that is the reason we always use this for high availability. So we don't use this for disaster recovery, or failover clustering is not tend to be for disaster recovery. It is only for the high availability, because if failure happens, it is a high availability. Why we don't use the disaster recovery? Can anyone tell me why failover cluster cannot be a disaster recovery? So what we understood about the disaster recovery,
Share disk.
exactly. That is the point, right? So it shares the disk. So let's say you have the primary and the secondary, and you use this as a disaster recovery. For example, whatever, like primary and disaster recovery. If it is a database mirroring or log shipping or even replication, it matters, right? All maintains the local storage, right? You will have its own files or file structure. And if there is anything happen, so this is isolated with each other, right? So isolated as in this storage at least is isolated with each other. It's a different storage altogether, right? If something goes wrong here, your disks are down, your servers are down, your everything is down here. But this will not be impacted. The server would be up and your disk will be online and everything is online here. Only database would not be in synchronous. Database would not be online. That is where you will have to bring the database online on the DR. But the disk, everything will be online. So there is no downtime for the storage if primary is down. But in the cluster, so what it has, let's say this is one server, this is one server. You will have a shared storage. The storage or the disk will be shared. So what will happen? If the disk is shared, what will happen? Let's say I have a user database one in the disk, shared disk. So if user database is in the shared disk, right? Only use a database in the shared disk. The reason I'll just mention this is not possible, but hypothetically I mentioned this for you to understand, right? So let's say if this is a user database and user database, the shared disk is corrupted or crashed, whatever happened. So what will happen to your SQL instances? Can anyone tell me? Your storage shared drive, which shares between the server 1, server 2, and only user database is in the shared drive. And this shared disk is crashed or corrupted or gone. So what will happen to your SQL Server instances?
So the user database are on the same storage, right?
So user database is on the shared storage, correct?
Shared storage. The instance is still okay because the master database is the one that system database is the one that hosts the instance. Only that the database may go on recovery mode there or something. But the instance, we can still connect to the instance.
Exactly. Yeah, that is the point. Thanks, Femi. That is the point where we have the like in the cluster. So we will have in the shared storage all the databases, including the system databases, will be in the shared drive, shared storage. Everything will be shared in the cluster. So if this is gone, if the storage is gone, which has the system databases and system files and every database that it matters, everything will be stored in the shared storage. If this is down, then your entire cluster is down. SQL Server. So this is the single point of failure, right? The reason it has the master and system databases, everything here in the shared storage. If something goes wrong, the entire SQL cluster would go down, right? So this is a single point of failure for the cluster, right? So in the cluster, you will have the instance and you add secondary as just a joining, adding node to the cluster. It is just a partner. It is just, you can consider that as a, another node which is added to the existing databases. That's it. Existing cluster. It doesn't maintain anything, right? So if the services are running on this particular server, wherever the cluster, wherever the resource is hosted, let's say the resources are hosted on S1, server 1. Then this disk also will be hosted on the server 1. This is also one of the resource, right? The disk will be hosted on S1. Now the disk will not be visible to S2. If the disk is not visible to the S2, then whatever services which are running on this S2 would not be running. So whatever services that we have on this S2 would be in stop state, right? The services will be in stop state and on the server 2, and the server 1 will have the services running because it has the system databases and system error logs, everything you will have on the one server. If something goes wrong to this server, then automatic failover happens and it start bringing the resources online, right? It start bringing the resources online. This disk also will move to this here. This disk also will move to another node. It is a network share, right? It is a shared drive. If it is shared, wherever it is, where if the server is down, then automatic failure happens. The other node will host the disk as shared storage. So services will start running on the another node. So since the services are running, then so you would be able to access your whatever, so application. So this is the reason that we call it as a high availability, right? So now let's say, for example, the storage is down. If storage is down, both nodes would not be able to communicate. Both nodes would not be able to access the storage because the entire storage is down. So if storage is down and if both nodes are down, there is no point you can have the DR. You don't have a DR here. I mean, again, like DR, the same that we were talking, right? Mirroring and log shipping. The same way you can configure a different server for DR, right? It can be database mirroring, or it can be log shipping, replication, whatever it is, you can configure another server, a part of these, to have a DR server, right? So that is possible, right? So this is the solutions that we have, right? So whatever we were talking, mirroring, clustering, and mirroring clustering mostly, right? Because these two are high availability purpose that we use. And both the options, without any third servers or without a third technology, we cannot maintain HRDR solution, right? Without third, I would say, like, so another solution, right? So without adding another solution, we cannot have a HRDR solution, right? So either you'll have to use mirroring with log shipping. So I'm not talking about the replication. This is just a, so personally, I don't use that replication, right? So I barely use replication, but yeah, so mirroring with the log shipping we can suggest, or even replication also can be suggested, but everything that you'll have to configure. So much administrative works in the replication that we have. And mirroring and log shipping you can configure to have this high availability and disaster recovery solution, or clustering with log shipping or mirroring. With clustering, I prefer to have that mirroring, right? Or clustering, I can have this log shipping as well. That is up to the solution, whatever we follow, right? So without adding another, so without adding another solution, we don't have a HRDR concept, right? So this is the solutions that we have so far. We do have log shipping. Sorry, we do have replication. That is mainly we use for disaster recovery. I'm not going into replication. That is one thing. Now, the client connectivity. How about client connectivity? If I'm talking only the high availability and disaster recovery, so I mean, I'm talking only the high availability purpose. If it is a disaster recovery, let's say, for example, you have a log shipping, primary and secondary log shipping. If primary is down and you brought this online, so how application will be connected? So in the application connection string, you'll have to change this. So let's say you have a XYZ server name, ABC as another server name. If XYZ server is down and your application connection string has to change with this name, so that they should be able to connect your disaster recovery server. Right? So one second. Right. So whatever we have, so primary and the secondary, right? So if some primary is down, the secondary data, that you'll have to change. Sorry, I got distracted. Okay, so ABC is the server name. So you will have to change this server name in the application connection string so that application should be able to connect. This is the application connectivity for the disaster recovery. Let's talk about the high availability concepts that we have. Mirroring, or before that, let's say clustering. So clustering, so what will be the client connectivity? Can anyone tell me how the application would be able to connect? So what if failure happens and how that works? How application will redirect? What is the client connectivity?
The instance name.
For the clustering?
Yes.
Okay. So instance name. Okay. Um, Instance name. What do you mean by instance name?
So name of the cluster, right?
Um, Name of the cluster. Okay. So let's say, for example, each server has its own, so instance name, or it can be anything, right? So it has to maintain a common point, a common, so name, so that whenever failover happens from primary to server, primary to secondary, or one server to another server, then your application should be able to connect without any, I would say, like, so without any manual intervention, right? So in that case, we have something called VNN, virtual network name, right? So virtual network name instead of instance name. So we have something called virtual network name, which is common between the servers, right? This is the virtual, right? So this is virtual, right? This is not a physical. This is a virtual we will create for the cluster. So whenever there is a failure happen, you can use this virtual network name and application should be able to redirect here and there, right? Even failure happens, this virtual network name is common between these two, VNN. And failover happens from here to here. Application is using this virtual network name, VNN, whatever virtual network name, and application should be able to connect even if failover happens from one server to another server. Let's say server name is XYZ. This server name is ABC, for example. Server name I'm talking, right? So the host name, XYZ and ABC. And virtual network name is the common between these two, right? So with this virtual network name, this is the network name, I would say, you will use this network name. So application will redirect connectivity even if there is a failure happens, right? So now this is interesting. What you use for mirroring? So this is one of my interview questions that I asked, right? So how you will redirect, right? So you have just an example, right? You might have heard always on listener, that also using as a connectivity redirect application. Clustering, we use the virtual network name. So what you will use for mirroring? Let's say you have a high availability configured between servers, primary, secondary. And primary is down, automatic failover you configured for database mirroring, and it will redirect or failover happens to secondary or mirror, whatever. Now application, what is the concept of high availability? Application, we no need to change anything. So automatically it should take care, or automatically it should redirect wherever the failover happens, wherever the primary is, right? That is what high availability. Now in mirroring, what you will use to connect? Anyone? So in the mirroring, we have, okay. Okay, so we have something called server name, right? Because mirroring is two instances that you are configuring, right? So you'll have to have the server name. Let's say, for example, you have a mirroring here between these two. This server is ABC.
So we
This is
can
your,
use,
sorry.
I think we can use IP address as well.
IP address we can use, but yeah, anything you can use, right? So, but how application will redirect if there is a failure happens? That is the question.
By using endpoint.
Application. Okay, when failover happen, our application redirect, right?
How application will
Is that
redirect? Yes, that is the question.
I think witness, right? Witness can instigate that.
That is, witness helps to failover at the
Yeah, I
database
think
level.
they will have to manually redirect the application.
Then there is no point of high availability concept, right? So if that is the case, then it is not considered as high availability. Let's say, for example, if your point, let's say it is a 24/7 highly transactional application or highly transactional database. And you have a DBA which works in day hours, like, so night, early morning 1 a.m., there is a failure happen. When no one was there and your highly transactional database is keep trying to access the database and it is failing. If you think that if someone comes and change the application connection string, and if something goes wrong in the midnight, and if you don't have an option, then your kind of application is down, right? Then there is no point of having a high availability.
Failover partner equal to mirror server.
Who is that? Santosh?
Santosh.
Correct. So we have something called failover partner. Thanks for that. So in the application connection string, so we have to have defined two parameters. One is the server name equal to ABC, the primary server, comma, failover partner. So failover partner equal to another server, XYZ, right? So you'll have to define these two in the connection string so that it understands, okay, this is my partner, right? This is my partner. And if this is down, connect to this. Or this is the current server. So it will not switch. So it doesn't matter until and unless you have these two keywords. So if this is primary, it doesn't matter like whatever keyword it is, right? So these two you will have to have. If this is primary and it understand, okay, the other server is ABC, then I'll have to connect ABC if there is a failure happens. Like this, you will have the automatic failover supported. And application will redirect without any manual intervention, right? If there is something happen here, the application will redirect to failover partner, right? So this is the way that we maintain high availability feature, right? High availability of your application, basically. High availability, see, what is high availability again? High availability, my intention is not to maintain at the database only. So not only at the database, right? Application also should be available. Application should be able to connect your data. Without that, there is no point of having high availability at the database level. So database level, you have a high availability. What if your application is not able to connect? Then there is no point of having high availability at the database level. Application should be available, or application should be able to access your database if there is any crash happen or if there is any issues on server. So application should be able to connect without any manual intervention or without much downtime, right? This is the solutions that we have so far. I think I'll stop here. We discussed SLG, we discussed RPO and RTO, and we were talking about, so what are all features that we have so far without introducing before introducing or even till today, without always on, we discussed, right? So there are few drawbacks, right? So all these drawbacks are combined, and the solution came as always on high availability. So what is the drawback with the database mirroring? Database mirroring is only for a single database, that one database that you will have to configure database mirroring, right? And secondary, in database mirroring, you cannot have more than one secondaries, more than one witness servers, sorry, more than one mirror servers in database mirroring. And database mirroring, you cannot read the data directly on secondary, right? You can create a snapshot and you can read, that is a different story. But secondary, you cannot read the data from database mirroring. That is the drawback. Log shipping, it is a disaster recovery solution, and you will not have a high availability feature. That is the main drawback with the log shipping. Clustering, you have a single point of failure. So if something goes wrong, so it's gone. If the storage is storage is down, sorry, if storage is down, that's a gone case, right? So if then you will not have any other option, any other solutions. That is a single point of failure. Same thing, replication. So replication, you'll have to have so much administrative works. And if you want to fail over, and you will have to bring the other server on, I mean, other server connection string pointing to the application, and that you can use. And it's a so much administrative work with the replication, right? These are all solutions that we have. So we will talk more on, like, so the other parts, like, so what is this, like how that maintains, what is the quorum, like, so we will talk about quorum models and the clustering, whatever, like we will discuss the basics tomorrow. Okay, so I will stop here. Any questions? So any questions? If you don't have, I'll hand over to Shanmukh if you have any. So we can stop recording and then Shanmukh, you there? You're on mute if you're talking. You are on mute.
Guys, can you hear me?
I can hear you now.
Yeah.
We'll stop the recording.
Yeah.